Alright, welcome to the first video for week 13. We're going to go over areas and perimeters. So here we have our rectangle. I think we all know the area of a rectangle. Right, the area is equal to the length times the width. Right? Length times width. Perimeter is equal to two lengths, because we have one up here and one on the bottom, plus two widths, because we have one over here on the right, one over here on the left. Not much to describe here. We have this information. We've been using it probably for a long time. Let's just do one practice problem. So we still have a rectangle. And now we know that our length, and I would label it always, right? Length is equal to 10. Width is equal to 7. We have units, those are centimeters. So when we find area, we do 10 times 7 to get 70, and that's centimeter squared. All right, for perimeter, we do 2 times 10 plus 2 times 7. So we get 20 plus 14. So that's 34. Because we didn't multiply those two pieces together, our units are just regular centimeters, not square centimeters. So that's how we would find area and perimeter of a rectangle. Square would be the same thing. I don't have any squares here. We could shorten it just a little bit, because if we have a square, then we know the length and the width are the same thing. So the area of a square is s squared, where s is the length of the side, and perimeter is just 4 times s. But let's move to something a little bit more interesting. So the next one we're going to talk about is our parallelogram. We have 3 pieces of a parallelogram. We have the length, which is sometimes called the base. And then we have 2 different heights. We have the slant height, which goes alongside of a side. And then we have the actual height of the parallelogram, which is perpendicular to the length. So you will often see a lot of perpendicular symbols in our problems on Khan Academy and the SAT and the ACT and in our book. You want to look for that perpendicular symbol, and the height goes through the shape. The base is alongside the bottom of the shape. The height can be anywhere inside of the parallelogram. It's just anything that's perpendicular to the side of the parallelogram you have. If we had this sideways, right, we could have this is the base, and then our height would be perpendicular to it like this. So we have a lot of situations, but let's look at one situation with numbers. So here we have our parallelogram, and we know the base is 10 centimeters and the height is 7. We do not have a formula yet for the area, and then perimeter would be difficult because we don't know what this is. Let's measure it real fast. You might be given this. This is 7.5 centimeters. So the perimeter is still the same situation. We have 2 times the slant height plus 2 times the base. So we have 2 times 7.5 plus 2 times 10, 15 plus 20. So we get 35 centimeters as our perimeter. So slightly more than the rectangle we just looked at. But what we're going to do, we need to find the area. And we don't know the formula for the area of a trapezoid yet. Parallelogram yet. So we need to make this look like a rectangle. And we have that right angle just like we do in the rectangle. So I'm going to actually take my scissors and turn this into a rectangle. All right. So I have my right angle. I am taking this piece that was on the left. I'm sorry for the focus not functioning right away. And then I'm going to move it, no magic here, I'm going to move it over here to the right. So now I have a rectangle. So now we have the length is 10 and the height is 7, right? So even though it's a parallelogram, we're still going to do kind of very similar to a rectangle. We're going to do base times the height. We just got to make sure we have the height which is perpendicular to the base. So here this would be 10 centimeters times 7 to get 70. And that's the same as our previous rectangle, right? We had our rectangle was 7 and 10. We had our parallelogram. Right, that we then turned into that same rectangle. The only difference is this parallelogram has a slightly bigger perimeter because of that diagonal than our rectangle. So that's rectangle and parallelogram. So if we want those formulas, we can write those. Perimeter equals 2 times the base plus 2 times the slant height. And then area is just base times height. This one is way more important for our study for this unit. All right. The last shape we're going to look at in this video, well, no, second to last, is our trapezoid. So for our trapezoid, right, now we have a lot of weird stuff going on. We have 2 different bases, right? A shorter one and a bigger one. We have the height, and then again, we have 2 different slant heights. So when we find the perimeter, it's not really a formula for this. Let's just say add all 4 sides. We don't really need a formula. There's no shortcuts for trapezoid. We just got to add all 4 sides together. For the area, that's what we want to try to figure out. All right? If we try to do what we did with the parallelogram and cut this little thing off, these 2 sides are at the same angle. So we're going to have to do something a bit more interesting. So let's look at an example. So same trapezoid, just I measured the sides. The top is 8 centimeters, the bottom is 12, and the height is 7. So instead of cutting along the height, what we're going to do I need this to stop trying to refocus. What we're going to do is we want to somehow do a similar thing where we cut a piece off and turn it into a shape we already know the formula for. So the only thing we can kind of do is cut it in half, right? How about I just fold it in half? Fold it in half so we can cut it in half. And then that way we can put these 2 sides together. So let's try that. I'm going to cut this in half. All right. So we have our 2 halves of the trapezoid. And now we're going to rotate it. So now we have this extra long parallelogram. We can even go so far if we really wanted to, if we don't trust this, right? Now we can cut along the height. And now we can form an actual rectangle, right? Where we have, and it's kind of easier if we see it as a parallelogram, we have our 12 centimeters right here. We add 8 centimeters, but our height now isn't our original. We cut it in half, right? So we have half the height. So that means instead of a whole 7, this now is 3.5, right? Just waiting for this to focus. We can't see the text on it. Okay. We have half the height and the 2 bases added together. So let's put this back to the original shape so we can actually do some math on the piece of paper. So that means for area, what we have to do, all right, area is equal to, we did that 3.5, and then we do 8 plus 12. So we get 3.5 times 20, and that would be 70, and our units would still be 70 centimeters squared. Right, so you don't have to cut up this trapezoid every single time you're trying to find the area of it. We have a short formula for it. And our formula for it will be 1/2 of the height times the quantity of base 1 plus base 2. Or just base plus base. And we can kind of see where that 1/2 comes from is because we cut the height in half to then form that the parallelogram. The last shape I wanted to talk about briefly was the rhombus, which is just a parallelogram. So if you have the height and the sides, then you can treat it just like a parallelogram. But I'm not too sure what all the examples from Khan Academy are, and I found this other formula online, and I wanted to talk about it. So here is a rhombus, right? And we know one of the properties is of a rhombus, the diagonals meet each other at right angles. So that's nice because we have a right angle, which means we can form some rectangles out of it. So in this example where I had the base and the height, if I flip it over to the back, here are those two pieces of information. We have P and Q, which are just the two diagonals, and they form at a right angle. So now we can cut along the diagonals instead of the height. We're left with these 4 triangles, but all right, we have one rectangle that is 1/2 of 12.5 and 1/2 of 8. And then we have another rectangle that would be the same thing. Right? So this isn't 12.5 anymore. We cut that in half. That would be 6.25. And that would be the same thing on all of these. And then instead of 8, we cut that in half. So we got 4 and 4 and 4 and 4. So if we look at this all together, right, we have this rectangle that we know how to find the area of. We do length times width, and that would be 6.25 and 8. So I don't know if this is going to show up on Khan Academy, but I wanted to show you this example just in case, where we took our rhombus and we cut it along the diagonals to then rearrange it into a rectangle. So that means if we have P and Q, our diagonals, the area is equal to P times Q over 2. And I'm going to write here P and Q are the lengths of the diagonals. All right. So that's how we would find the area of a rectangle, parallelogram, trapezoid, and a rhombus. Next video will be about triangles.